fundamental principle of counting. Now you can be asked to state this in an exam, so you need to learn this off by heart, but when you understand the maths behind it, it'll be easy to recreate. You don't have to use the letters M and N, you can use any letters. And it states, if one trial has M possible outcomes and a second trial has N possible outcomes, then the first trial followed by the second trial has M times N possible outcomes. Now, the fundamental principle of counting is a quick and easy way to determine the number of outcomes of two or more trials. So let's take a really simple example of you go into a restaurant and there are 3 starters and there are 4 main courses. How many possible meals can you have? And you can see the answer is 12. So really simple maths behind it. 3 by 4 is equal to 12. So you could write all these down. You could have starter A, B, and C, and mains D, E, F, and G. And when you write all the combinations of those 2 letters down, there's going to be 12 combinations. In some restaurants, there's loads of meals, loads of things in the menu. You wonder how they cook them all. But in this restaurant, there's 10 starters, 10 mains, and 10 desserts. So how many possible meals are there in this restaurant? 10 by 10 by 10, which from your rules of indices is 10 to the power of 3, which is a 1 with 3 zeros. So there's 1,000 possible different meals you can have if there's 10 starters, 10 mains, and 10 desserts. And the maths behind the fundamental principle of counting, it doesn't get any more difficult than this. So there's other keywords that you need to know for probability. A trial, and we're going to look at an example of rolling 2 dice now in a minute and all the possible outcomes. A trial is the act of doing an experiment in probability. Example, rolling a dice or 2 dice or 3 dice. An outcome is one of the results of the trial. For example, rolling a 6 or in 2 6s if we look at an event down below. A sample space is the set of all possible outcomes. A two-way table for rolling 2 dice, which we're going to see now. And an event is the occurrence of one or more specific outcomes. For example, rolling 2 6s. So let's have a look at a two-way table. So write all these words and their examples into your copybooks before taking down the two-way table for 2 dice. So a really popular question is a two-way table, 2 dice, you roll 2 dice and you add the scores together. And you're asked to fill out all the possible outcomes. So a 1 and a 1 is a 2, a 1 and a 2 is a 3, and you can see the pattern here. 6 and a 1 is a 7, and then a 2 and a 1 is a 3. And then it goes 4, 5, 6, 7, 8. A 1 and a 3 is a 4, 5, 6, 7, 8, 9. A 1 and a 4 is a 5, 6, 7, 8, 9, 10. 1 and 5 is 6, 7, 8, 9, 10, 11. And 7, 8, 9, 10, 11, and 12. You could be asked the probability of scoring a 10 or higher, a 4 or lower, and these kind of things. So you can clearly see which one the most of is, which is the 7 going diagonally across. And we're going to look at now the probability of each outcome, and there's a pattern that will emerge for the probability of each outcome. So what about the probability of getting a 2? So always on the bottom, we have the total possible outcomes. And from the fundamental principle of counting, from up above, 6 by 6 is 36. So there's 36 outcomes. So every probability is over 36. And the probability of getting a 2, you can see there's only one of them. It's 1 over 36. And the number 1 is 1 lower than 2. So here's your pattern. The probability of a 3. You can see that there's 2 of them. 1, 2. So a 2 and a 1 or a 1 and a 2, there's 2 over 36. You don't have to simplify it to 1 over 18. We'll always leave it as the total possible outcomes on the bottom to see that we're using the right number. So the pattern is the probability of a 4 is going to be 1 less, so it's going to be 3 over 36. The probability of a 5 is 4 over 36. Let's just double check. You can see here there's 4 of them. The probability of a 6 is 5 over 36. The Probability of a 7 is 6 over 36. Let's just double check. We have 1, 2, 3, 4, 5, 6 sevens. Now, this is where it changes. The probability of an 8, you can see the pattern starts to reverse. So you can see here, 1, 2, 3, 4, 5 8s. There's going to be 4 9s. There's going to be 3 10s, 2 11s, and 1 12. Now, 1 and 12 is 13, 2 and 11 is 13, 10 and 3 is 13. So the number on top here and the probability of the number you're getting have to add up to 13, or we just say, well, we're reversing the pattern and we're going back 5, 4, 3, 2, 1. So 5 and 8 is 13. That's how I remember it. That's how I was taught it. The probability of 9 and 4 is 13. So if you can remember this pattern, it really becomes easy to learn off. The probability of a 10 and 3 is 13. The probability of 11 and 2 is 13. And the probability of a 12 and 1 is 13. So these are all the probabilities of rolling 2 dice and adding the scores together. So here's 6 quick questions to test yourself with. Try to do it on a fresh page so you're not looking at the answers. Probability of a 6. Can you remember the pattern? 1 less up to 7, so 5 over 36. The probability of less than a 4. Well, let's go up and have a look at our table and we'll add these together. So the probability of less than a 4 doesn't include 4. So we have a 3, a 2, and a 1, 3, 2, 1, 6. Greater than 11, well, the only one greater than 11 is a 12. So 1 over 36. Greater than 10 has to be 11 or 12, and there's 2 11s and 1 12. So 3 over 36. And you can see I'm not simplifying these fractions. The probability of a 10 and 3 is 36. And the probability of an 8 and 5 is 36. So if you've gotten these 6 correct, and you've remembered all the probabilities to do it, rolling 2 dice, move on to the next video.